Welcome students to your favorite channel Pradeep Sir Classes has PSC, and today we are discussing about the last two numericals of unit and dimension and volume 1 chapter 1 question number 18 and 19, and it's all about the numerical king series, that is the solution of AC Verma that you are followed till now. Okay, so if you are in the first in that particular class, then go back to the previous lectures and enjoy all the numericals and then come back again. So students, and now I suggest you that you can check the description box, that all the numericals related to unit and dimensions are given within the description box. Okay, so let's start with the numericals, that is question number 18. First of all students, these 18 number numericals are about the dimension of homogeneity, and this tells that the dimensions of the two terms, or in a particular equations, the LHS is equal to the RHS. So the dimensions of equations of all the terms are homogeneous. Okay, so the dimensions of each term is equal, that is the dimension of the left hand side is equal to the dimension of right hand side. So question number 18. Students, you have to test or verify the equations dimensionally. So the equation is question number 18. Question number 18, and A, that is H equal to 2s cos theta by rho Rg. Students, in a particular equations you have to know all the related physical quantity and with their dimension. So first of all, you have to write down all the dimensions given here. What is H? Here H is given, and in questions H is height, so the dimension of H is L, and the next one is S. S means it is surface tension, and you have to know that surface tension equal to force by length. And what is the dimension of force? There is mlt minus 2 by L. There is L cancel this one, so mt minus 2. So mt minus 2 is the dimension of surface tension, and the next one is rho, that is density. Density equal to mass by volume, that is ml minus 3, ml minus 3, and r. So what is about r? R is the radius. Yes, R it is a length, dimension of length, so R it is dimension of R, and this is equal to L, and G is the acceleration due to gravity, so it is LT minus 2, and you have to this is so the LHS dimension of LHS is equal to H, that is L. Okay, so dimension of this one is this, and you have to put all the dimensions of RHS. So RHS means dimension of RHS, and this is equal to you have to substitute all the dimension except the numerical value. So numerical value is 2, and the S equal to surface tension, so surface tension equal to force by length, that is mt minus 2 into cos theta. Cos theta is a ratio, since cos theta equal to base by hypotenuse. So this is length by length, so this is a dimension, it is a ratio, so it is a dimensionless physical quantity. So this is 1 divided by density equal to mass by volume, so ml minus 3, and this is L, and this is LT minus 2. So m and m cancel this one, L square and L, this cancel this one, and it remains L, and when L minus 1 comes into a numerator position, then it is L, and here t square cancel, this one also cancel, so L. So the dimension of LHS, so the dimension of LHS is equal to the dimension of RHS. Okay, so you can write it is dimensionally correct, or it may be correct, or you can write it may be correct, because if 2 is not given here, suppose it is given 3, then also you can say that the dimension is correct. So dimension, it is the demerits or of dimensional homogeneity, that is we cannot determine a particular constant value with the help of dimension. So students, we can write it is dimensionally correct, or the equation may be correct. Okay, so you have to just substitute the RHS with the dimension of LHS with the dimension of RHS, and you have to show this, yes, this is dimensionally correct. So for the next one, write down the next one, that is B. That is B equal to B, and it is equal to, it is velocity equal to P by rho. What is the difference between B and D? B is a velocity, and if we write like that, then it is frequency, or it is known as nu. So this is velocity and this is pressure. Pressure equal to velocity, that means LHS, dimension of LHS is equal to LT minus 1, and the dimension of RHS, is equal to root under of P. P means M, L minus 1, T minus 2 by density, mass by volume. So mass and mass cancel this one, and this one equal to root over of L square. Students, minus 1, this is minus 3. So when it comes upon the numerator, that is plus 3, and minus 1 plus 3, that is 2, and this is T minus 2. So L and T minus 1. So the dimension of RHS is this one, and this is also equal. So we can write dimension of LHS is equal to dimension of RHS. Okay, so dimension of LHS is equal to dimension of RHS. That is, we can say that this is also dimensionally correct, or the equation may be correct. Okay, equation may be correct. So the next one is question number C. Question number C. And students, this is the benefit of online study, that if you don't realize at a particular sort, then you can review it. So this is 8 into eta into L. You can easily pause that one and write down the numericals again. This is a pressure, and this is length, and this is time, this is eta, coefficient of viscosity, and this is length, and this is volume. So LHS, dimension of LHS is equal to volume. So this is L cube, and dimension of RHS is equal to pressure. Pressure means M, L minus 1, T minus 2, and this is L to the power of 4, and then T divided eta. Eta means M, L minus 1, T minus 1. Eta, and then L, there is L. Okay, so you have to know all the dimensions. First of all, the students, for question number 18, you have to know all the dimensions given here below, and then put the dimension within a particular place. There is dimension of LHS, when then in place of V we can write L cube, and in place of the different physical quantities you have to substitute the different one, and then cancel this one, and this one also cancel, and this is T dash, T minus 1, sorry, T minus 1, and here T minus 1, so T cancel this one, and this, and the remains L cube. Okay, so you can write dimension of RHS is equal to dimension of LHS. So this equation is also dimensionally correct. So for the next one, it is a frequency. So question number D. Question number d, and this is frequency equal to 1 by 2 pi and root over of. As students, if you feel trouble in that particular numericals, then go back to my lectures of different about different dimensions, and all the concepts are clearly understood from that different types of numericals and related with all the numericals related with unit and dimensions given. And so nu equal to 1 by 2 pi root over of mg L by I. What is I? I equal to moment of inertia. So for that one, LHS dimension of dim of this one nu equal to t minus 1, and the dimension of RHS this is equal to, this is a constant, so root under of m mass. It is mass per unit length or mass, you have to know. So m, no, so you have to take is as usual you are know, so it is a mass. So mass equal to m, and then g means acceleration, lt minus 2, and then length, then moment of inertia, I equal to, we know that m square, moment of inertia, that is m, and this is L square. So m and m cancel, L square cancel this one, so t minus 1, so t minus 1. So this one is equal to this one, so we can write the dimension of LHS is equal to dimension of RHS, and the equation is dimensionally again correct. So all the equations 1, 2, 3, 4, A, B, C, D, all are dimensionally correct. That you can say that this is equation, and this equation may be correct, or this is dimensionally correct. And for the next one, it is a important, very important numericals, and it frequently comes in joint or NEET exam. So so you have to done these numericals sincerely. So question number 19. Question number 19, what is about it? There is an integration sign, and you have realize that this is the integration of dx by root under of this is, and this is equal to 1 by a and sine inverse of a by x. So students, you have to know that what is the physical quantity related with it. Don't go for the details, what is integration, how it is comes, and these are not required for the numericals, just you have to know the physical quantity related with. So dx, what is about dx? Dx, student, means small length, okay, small length, so it is L. So the dimension is L, 1 centimeter or 2 meters, it may be 1 centimeter, the dimension of 1 centimeter is L, and if it is 1 kilometer, then it is also L. So what is about the dimension? If it is length, then it is L. If it is time, then it is time. If it is mass, then it is m. So dx is small length and it is L. Okay. And x square. So x square. Here, student, if we take LHS, then dx. Dx means L and root under of. Root under of. You have to take any one of the term. Why? If you write down 1 centimeter plus 2 centimeter, then it is 3 centimeter. If you write 1 centimeter plus 2 kg, then there is a question mark. Why? Because these two physical quantity are not same. So you can't add 1 centimeter with 1 kg. Okay. So here it is given a square minus x square. So it is easily, you will know that a square, the dimension of a square is similar to that one, that is x square. So it is you have to take here as L square. Okay. So it is L and it is L square, and when it comes in the open, then it is L divided by L, and that is 1. So this term is dimensionless quantity, and this term is dimensionless. Since this is a ratio, we know that it is a trigonometrical ratio, and this is it may be perpendicular by hypotenuse. So it is a sine inverse. It may be sine inverse or cos inverse or cos theta or sine theta. All are dimensionless. Okay, so it is also dimensional quantity because this is a ratio. So 1 by a equal to 1. Okay, so 1 by 1 equal to, we can write as 1 by a, and you can write it as dimensionally because the equation is different. So it is dimensionally, you can write 1 equal to 1 by a. Okay, this is a dimensionless and this is 1. So you can write this one. So a equal to 1. And students, what is the question? And let x and a stand for distance. Oh yes, it is a distance, and a is also distance. And is this is dimensionally? This equation is dimensionally correct or not? So this is dimensionless. This is dimensionless, but 1 by m means 1 by L. So the RHS is 1 by L. So this is 1, but this is 1 by L. So this is dimensionally, you can write this is not equal to this one. So this equation is dimensionally not correct. Okay, so this equation is dimensionally not correct or incorrect, you can write that. So this equation is incorrect dimensionally, and but 18 number question that is related with 4 numericals, all are correct dimensionally. So you have to so I complete all the numericals, that is from 1 to 19 of unit and dimension, students. And last of all, I want to say that all the links are given in the description box, and you have to check and write down all the numericals. And if you are a 12th student, then go back for another numericals that is related with the electrostatic field, potential and gravitation, and all the numericals are also running. Okay, so let's enjoy all the numericals, AC Verma, and wait for the next class, and that will be start with a vector and the another different numericals, that is chapter 2. And the chapter 2 is physics and mathematics. Oh, okay. So physics and mathematics means it is depends upon the significant figure. It is on the differentiation. It is on the new applications of integration and vectors and all the related with this. And then chapter 3, that is rest and motion. Okay. So let's enjoy the numericals again, I say, and continue your study. Thank you. And if you think that wow, what a concept, then subscribe. Okay, thank you.